I created this sort of in my spare time to say, to get the message out, guys, let's change. My colleagues in the industry I talk to and say, let's do this. And it's one of those grassroots thing that says, yeah, let's think about this. If you're designing a satellite, let's think about recovery. What am I going to do with this? To the corporations, I would say, when I put myself in a position of young engineer in 50 years or 80 years, it says, they say, hey, Mike, we're going to go recover the satellite, go figure it out. And I say, okay, so if I had to figure that out, I say, well, how was it built? Well, we don't know. Those records are lost. What materials were they using when they built it? We don't know. Those records were lost. I say, okay, let's keep those records. Let's document our designs. Let's make them, make it so we can recover them. Let's stop them from spinning in orbit once they're passivated. Let's study how we can create some drag device so that they'll stay stable and they won't spin so fast we can't recover them. Let's think about the challenge that somebody's going to face in 50 or 80 years or 100 years when they go up, because everything's going to have to come down at some point. The ecosystem that science fiction is built in our minds about what we're going to do in space, and everything we're planning to do in space requires us to have access to space, and we can't do that if it's littered with debris. So we're going to have to go up and get this stuff out of orbit at some point in time that's up above the, say, 700 kilometer altitude. And remember, at low Earth orbit, because we stuff a bunch of stuff in low Earth orbit because it decays quicker, means there's more stuff to transit as we go up and come down. So it doesn't solve the problem. It just relocates the problem to a space where everybody wants to be, because it's where they need to be to meet the 25-year rule. But we need to look at that whole ecosystem and how we're going to operate in it. So it doesn't really matter where we put it. We're probably going to have to be handling it at some point in the future. And that means that, for example, right now the rule says that if you're going to be in low Earth orbit, we want you to look at whether or not it needs a controlled or uncontrolled reentry so it doesn't present any risk to people on the ground. Well, we should be doing that for everything going in space, because we don't know how we're going to dispose of it yet. It may be that things in medium Earth orbit at the global, at the navigation level are going to come down as well. So right now, today, with the engineers that are building these satellites, we should be analyzing the designs with the NASA model for reentry to decide whether or not they need controlled or uncontrolled reentry, and put that at the licensing level, so that at one glance with the document, somebody can say, oh, that needs controlled reentry or not. Because at some point in time, those records of the detail of the design, you don't want to have somebody looking back and say, well, is this going to actually melt on reentry or not? So it's just, these are small steps. They're not expensive. They just need to be done today, because somebody in the future is going to have to try to figure this out, and we should help them do their job, as opposed to making it more difficult to them because they've deployed a sensor over the launch adapter ring, and it's not going to cost. We're going to have to use a harpoon to go get a satellite out of orbit. That just doesn't make any sense.
Okay. And I can tell our viewers and listeners from many, many industries wide, it's not just space, this problem of keeping records and documentation. It's a boring word, documentation, I understand, and nobody likes to hear it, but it's critical, and it's far worse as a problem than you might think. You might think, well, of course companies keep records. No, it's not so great.
Even more interesting is if you look at the shuttle recovery of the Westar and Palapa satellites, when they finally, and this was concurrent with the design team that had built the satellites at Hughes, and they had built a truss structure for the shuttle bay that to hold the satellites in when they came back to Earth. And they tried to use the truss structure, and it didn't fit because one of the satellites designs had changed between the drawings and the build, and they weren't documented. So when they went and built this expensive piece of gear, they didn't build it correctly with the right clearance because the design had changed. And that was just over the course of a year or so. So we're talking 50 years. It's impossible to believe that we're going to have good records if people don't work at it really hard.
And again, it's easy to do now, but difficult to do later. The information just disappears. Tell us about the 25-year rule that you mentioned.
Well, I don't know the exact history of it, but my reading of what it turned out to be is, I guess a bunch of people got together and said, what about 10 years? Everybody said no. What about 25? Yeah, we could live with that. Yeah, let's live with that. Okay, 25 year became the rule, but it didn't have any rigor attached to it. It was sort of like by default. It was like long enough that nobody would really everybody's careers were over by that time, perhaps, and they didn't really think it through. And it's out there now, and people are trying to figure out, and it's led to some interesting things about the altitudes we choose to operate in. It's not complied with vigorously. And so as a rule, it's one of those things that, yeah, it's a good guideline, but it's not deterministic in terms of what the risk is. And we kind of use it as a touchstone, but it's only kind of relative. I think it's kind of immaterial, though. I think there's a way to get, the point is, you have the 25-year rule, but if you were to make a rule that said that everybody operating something in space, regardless of whether it's operating or not, the fact that it's in space, that you, the company that owned it, had to provide ephemeris on that object for its entire time in orbit. You think about this: it dies. You're not generating any revenue from it anymore. It's not conducting any work for you, and you're paying, say, $5,000 a week to pay some company to provide ephemeris from some tracking station somewhere. You'd be motivated to get that down sooner than 25 years. So the 25-year rule could become moot if you were to make operators pay for tracking the burden they bring to the space surveillance network for their object in orbit, for their debris that threatens all the operating satellites. So I think the 25-year rule would kind of go by the wayside.
More engineers are not going to solve your problem. It's not a technical problem in that sense. It's a process problem. And the time to fix your processes was 20 months ago, and the second best time is today. This is Jason Kanigan, the president of Cold Star Technologies and the host of this podcast, the Cold Star Project, which is all about identifying and solving process problems for space companies, because that's what we do. And you can hear the entirety of this episode by following the link in the comment below.